We're going on to solving systems of equations graphically, but this time it ain't just lines. We are going to look at some other shapes that cross each other on a graph. Well, right now you should have three basic shapes that you should know. Absolute value, linear, and a parabola. Well, an absolute value, you may remember, looks like this, and we saw it in the beginning of the year. It's two straight lines going off in a V shape. And of course, on the end, we have arrowheads to represent that it goes on forever and ever. Straighten that out, make that look pretty. All right, then we have, of course, our linear function. And our linear function is basically a straight line. The new one that we're going to look at is a parabola. So a parabola looks like this. Now, you may be saying, yeah, we know what a parabola looks like. We saw it last year. Awesome. But the parabola is the first time we're getting to see some curves. Now, we're going to study a lot about parabolas, but not for another two sections. Right now, we're just going to get used to seeing them and how to type them into a calculator. So the next thing we need to know, since we're going to be typing things into a calculator, are their forms. So remember, an absolute value is the form y equals with absolute signs, and then our equation can be inside. Linear is the form y equals mx plus b, right? We know that. Yes, Big Poppy. He's barking at squirrels again. And a parabola looks like this. Notice something different about the parabola? Yeah, the equation looks a lot longer, but this is what I want you to notice. It's got an exponent. That's what chapter 6 is about, exponents. But what I want you to know about an exponent is that it makes a graph curve. Notice these don't have exponents, so that's why they're straight. All right, example 1. The functions y equals negative x squared plus 4x and y equals negative x plus 4 are graphed to the left. Hopefully now you can pick them out. Obviously, this one is the straight line. This is the parabola, and what gives it away is that lovely exponent there, so we know it's going to curve. If we were to solve the system of equations, what would our answers be? You're like, oh, this is easy, Mrs. Trillin. You gave us the picture. All we got to do is look at it, and where do they cross? Oh my God, I think she's lost her mind. This is way too easy. All right, so they cross there. So that's the point 1, 3. And then this other point is 1, 2, 3, 4, 0. Wow, is this section going to be easy? All right, now I got down here another question. Where does x squared plus 4x equal negative x plus 4? Well, Mrs. Trillin, that's the parabola again. See, it's right there, and that's the line. And you just asked me where they cross, and I just gave you the answers. What's the difference? Aha, there is a big difference here. And this is where you have to be very particular, and you have to read math carefully. You see, in this first system of equations, notice there were two variables, a y variable and an x. So what my answer must include an answer for y and an answer for x. But if I look at this, I do not see the letter y anywhere. So this is just asking me what x values make this parabola equal this line. So yeah, it is just as easy, but all I'm looking for are just the x's. So the answer is x is 1 or x is 4. That's all I'm asking is just the x variables. Now, you're going to see y. I don't need the y in the future. We're just trying to get you used to looking at the difference, reading carefully, seeing two variables, seeing one variable. All right, example 2. The graph negative 2x squared minus 4x plus 6 is shown at the right. Beep! There is an exponent, so it's got to be a parabola. All right, where does this parabola equal 0? Huh? Oh, wait a second. Where is y equals 0? Because remember, we're hiding that y. So y equals 0 is right here. So where does that parabola cross there? But remember, I'm going to look closely. Do I see a y anywhere in here? No. So all I'm looking for are the x's. So what x values make my parabola result in the number 0 coming out? If I put in a negative 3 or if I put in a 1. See, if I come down here and check that, negative 2, let's put in a 1 first because putting in 1 is always easy. All right, so that's 1 squared is 1, negative 2 minus 4 plus 6. Does that get me 0? Yep, negative 6 plus 6 gets me 0. And that's all they were asking. What x values result in an answer of 0? And likewise, if I put in a negative 3, it would work also. All right, let's go on and see what they're asking in the second part. What is the answer to the system of equations? See, I see a y, and I see an x equals 0. Haha, tried to trick you, didn't I? All right, so in this question, they've got my parabola. But now it's x equals 0. So they want me to take this line right here and move it to x equals 0. And x equals, thanks to Mr. Sloopy Face, we know x equals goes up and down like that. This question, tried to trick you, is a totally different answer. And it is the answer 0, 6, 2, 3, 4, 5. Just check myself. Because this one asked for a system, a y and an x have to be included in my answer. And then I gave you a totally different line. I didn't ask you to put 0 in for y, I asked you to put 0 in for x. All right, example 3 and example 4. Hey, wait a second, there's no pretty picture to help me. Well, let's understand, first of all, that we could solve these the good old-fashioned way. We could add 3, negative 1/2 x plus 9 equals 4x. 9 equals 4.5x. When I move that 1/2 x over, x equals 2. I can also do it on a calculator. Now, here's the beauty of math. Sometimes it's easier to do it on a calculator. Sometimes it's harder. But how would we do this equation on a calculator if need be? Well, we know the answer is x equals 2. And notice there was no y's here. All they wanted were x's. So what we have to do is we have to look at this as two equations. We have to look at this as the equation y equals negative 1/2 x plus 6. And this is the equation y equals 4x minus 3. I can come over to my graphing calculator and I can type in negative 0.5 4x plus 6 as my first graph, and then my second graph is 4x minus 3. Now, both of these are going to be two lines. I don't see any squares going on or any absolute value signs, so it's just going to be two little old lines crossing each other. And look where they cross each other. They cross each other at this point right here. And that is the point to, let's see, 1, 2, 3, 4, looks to be 5, but hey, who cares? In the original problem, we didn't care about the y value, did we? Because the original problem only had x's. And so that's why when we solved it, and when we look at it for an answer from the graph, we only care that the x value is 2. There's no y value there. All right, so for the next one, we are going to have to use a calculator because you don't know how to solve equations that have x squared in them. Not yet, but you will. So you have to again look at this example and realize if I gave you example 3 on a test and asked you to solve it, you would be able to solve it algebraically or graph it. If I gave you this one on a test, you would realize you don't know how to solve it algebraically yet. You have to graph it. You have to look at it as two distinct graphs, the left side graph and the right side. So I'm going to get out my calculator and I'm going to type in what I see. Well, the first one is x squared minus 7x minus 7. And then the other one is negative 3x plus 5. Negative 3x plus 5. All right, I should have a parabola and a line crossing each other. There's my line. There's my parabola. Hey, wait a second here. Got a little bit of an issue. There's a bigger picture of it. Looks like it's crossing in two places, and I can't see the two places. Well, I can rework my window so I can see them. Let's do that. Let's go over here to my window. And looks like my y values, I have to expand along my y values. So instead of a minimum of negative 10, let's do a minimum of negative 20. And let's do a maximum of 20. And let's see what this graph looks like now. Much better. I can see both points. So I'm also going to let the calculator figure out the answer for me. I'm going to go into second function, calculate. Remember doing this? I'm going to go to the intersection, and I'm going to press enter 3 times. 1, 2, 3, and voila. They tell me the first x is negative 2. There's another answer to that. So we're going to come back here and we are once again going to do second function, intersection. And I'm going to move my cursor so that it's close to the second point. And then I'll press enter 3 times. 1, 2, 3. And my other point is x equals 6. And that's all they wanted. they only wanted my x values. Don't see any y's in here, so they don't want my y values at all. All right, here's an absolute value graph. So real quick, let's see if we can run through these questions. This is an absolute value. I see my absolute value symbols, and here's my darling letter V. Yay, I don't see any y's there. This is simply asking me, where does my absolute value cross 0? All right, well, I'm going to go get a line right here. Where does it cross 0? It crosses 0 here and here. So it only wants my x values, 1, 2, 3, 4, 5. So my answers here are if x is -5, 1, 2, 3, or if x is 3. Where does my graph cross -2? All right, so we need to now have a line that goes through -2. And it crosses the line -2 at that point and that point. But again, we only want the x values, and the x values are where x is 2, 1, 2, 3, 4, or x is -4. This is pretty easy. What's the last one asking us? Where does our absolute value cross the line x -1? All right, so we just have to do a little cleaning up over here. Let's get rid of one of these lines. And now I need -1. Well, I'm going to graph it. Here's -1 right here. I have a slope of up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, up. There's an intersection right there. And if I were to graph it the second way, there's my second intersection. 1, 2, 3. So where x is -3, and where x is 1, 2, 3, 4, 5, and where x is 5. See you tomorrow.